Hi, I'm Phil, and I want to talk about my latest version of the FarmBeats project. This is called FarmBeats RMS. The R is for remote, and the MS is multi-station. That is, you can operate the FarmBeats hardware in the garden or on the farm remotely. And you can do this either with Wi-Fi or with LoRaWAN. Multi-stations means that you can have many points or many hardware configurations. Each one is a station, and you can select the particular station of interest to be routed to Microsoft Excel for further analysis. So my objectives are to improve the productivity on farms, minimize the wastage of water, and provide the optimal level of lighting for each plant. So it's got to work in an outdoor area, and I'm going to compromise a little bit on the protection of the hardware to minimize the cost. As we mentioned, it's going to support multiple stations, and each station can collect environmental data of temperature, humidity, and the version I'm going to show you is using the temperature and humidity sensor called the Grove DH11. So in this version, we are not measuring pressure, but we are measuring the light level, not only just light, but the visible light, infrared radiation, and ultraviolet radiation. I'm going to measure the soil moisture and the soil temperature. And we're using a relay which will be configured as a pump control. So we can turn on and turn off the pump depending on the moisture level in the soil. And all of this data is going to be routed to the Windows PC. And on Windows, I'm also using Excel and another program that helps in the communications called Microsoft Data Streamer. So one of my objectives is to use this in a wider area, anywhere on the property, and I'm going to use wireless. And I also want to do some controlled studies so I can see what the impact is of different watering procedures, different procedures in lighting. And I can also want to compare different sensors, how reliable and how accurate they are. So all of this is based on the Grove Smart agricultural kit for Raspberry Pi, and it was done as part of the Microsoft FarmBeats project. It collects data in real time, and you can see the data and see the visualization of data in Microsoft Excel. So it introduces you also to the Microsoft Responsible AI framework. And the goal is to keep the hardware cost down, so it's quite affordable by agricultural students. And I ordered this whole kit back in March this year. So the applications are in STEM education, but also to enable farmers to optimize their production with precision farming and to use smart agriculture and the latest internet and the Internet of Things tools to improve the productivity on the farm. And the other technologies is to utilize artificial intelligence and machine learning and communications technologies that allows all of the sensors and actuators to be connected to the internet. So the kit, which is available from Seed Studio, cost me $104, and it's gone up since then. And these are the components that you get in the kit. So you'll notice most of these are Grove sensors or actuators, and you can build on these using other components in the Grove library. An example might be that you may want to measure the pH level in the soil, and there is a Grove pH sensor that can be added. So on the software side, we're going to use a combination of software. One of them is Mosquito, which is an MQTT server, and it provides a service on the Raspberry Pi. Also on the Raspberry Pi, all the management of the sensors and actuators is done using MicroPython. And I'm using Node-RED to route the serial communications port to MQTT. And I'm using the desktop version originally, but it's much better to use the online version of UI Flow. And UI Flow, I'm using it here in another little computer called the ATOM Matrix. And it's going to be used in conjunction with a Windows PC to monitor the Wi-Fi communications and to route the communications via another serial port to the Windows PC, which will be used indoors. So that's the combination of software which is used on the Raspberry Pi outside. And inside, we're going to get the data from the ATOM Matrix via a serial port, and Data Streamer is going to send it to Excel. But we not only visualize the data in Excel, we use an additional tool from Microsoft called Load that allows us to use machine learning and artificial intelligence. So you can see there's quite a bunch of software here which is working together to try and provide a control and feedback system to provide control of light and water on our plants in the garden or on the farm. So this is the sort of thing you can do with Microsoft Load. It can help us recognize the plant species. And if we take this further, once we've recognized the plant species, we can then provide a controlled treatment of water, light, and even fertilizer for the particular plant that we've identified. We can also identify diseases and pests using the machine vision. And when the plants are growing, they get bigger. And depending on the size and the color, we can measure the growth of the plant. So this is the procedure recommended by Microsoft. First of all, exploring the kit with the Raspberry Pi, the sensors and the actuator. Then configuring the PC with the classroom material. And finally, using Excel and Load to get better output from your farm or garden. And this is what it should look like on Excel. So what we're doing here is to look at the measurement of soil temperature, air temperature, sunlight, soil moisture, and air humidity. And this is using the live sensor dashboard on Excel. And to achieve all this, we send the data using a communications protocol, which has 4 groups of information, but they're all combined together in a single package. And the format is comma separated values that Excel can recognize. So let's have a look at my latest project, and I've added this to the original mind map that I've demonstrated earlier. So these are all the projects that I've done with FarmBeats, and the latest one is FarmBeats RMS. So FarmBeats RMS, I'll have a look at what the objectives of this project are, have a look at the hardware and the software, show you some of the results, and give you some references. So this is, the picture shows the FarmBeats kit outside, working in a vertical garden. And I still want my Windows PC to either be connected or I can disconnect it, but the Windows PC with Excel will be inside. Even though it's on Wi-Fi, I still want to have two-way communications. So the agent on the PC, which provides feedback control of the relay, the Excel program can issue a command depending on the levels of water, sunlight, or some of the other sensors can configure that agent. And I want to be able to use multiple stations. So here I've got one station, and this will be station 1, but I want to test this on 2 additional stations. So I want to make it low cost. So even though you've purchased the Seed Studio FarmBeats kit, the only additional cost for the Wi-Fi and multiple station control will be no more than $15. So this is the hardware that I'm using. We build on the original FarmBeats kit with a Raspberry Pi, but we add on a M5Stack ATOM Matrix computer. And the costs vary from $7.50 to $15.50, depending on the configuration of the ATOM that you select. So you can see on the top there is the FarmBeats kit, and on the bottom is what the ATOM Matrix computer looks like. And this is how it's all built up. So we start off with a Raspberry Pi Model 4. We add on the Grove hat, so the Grove sensors and the actuator can be connected. And these are all connected with Grove cables. And now we've configured the ordinary FarmBeats installation. So you can see on the right, we've got the Grove dual buttons, the Grove DHT11 temperature and humidity sensor, the relay, and the soil moisture. And on the bottom, we've got the soil temperature. And on the left, we have the sunlight detector, which is connected by an I2C interface. On the Raspberry Pi GPIO pins, we add the serial port. And the serial port that was in the Seed Studio FarmBeats kit was defective. And I've asked Seed Studio on multiple occasions to replace it. So I can't wait. I've already waited 6 months. I've purchased this for about $5 on eBay, and it works even better with minimal issues on installing the drivers on Windows. So normally you would connect that TTL to USB device, would normally go straight into the Windows PC. But my modification is to feed it back in to the Raspberry Pi. And the Raspberry Pi will have two extra pieces of software installed that will route that data by Wi-Fi to our home Wi-Fi server. And the M5 ATOM Matrix computer will pick it up and feed it on via serial port to Microsoft Data Streamer and then on to Excel on a Windows PC. So here's the software. On the Raspberry Pi, we have, in addition to the original set of programs for Python, we have Node-RED, which is providing a web service. And that means that we can access and develop the software on a Windows PC inside, even though that the program or in the hardware is outside. The additional feature that I've added is that Node-RED, the Node-RED server and the MQTT server are both initiated as a service of auto booting. For the M5 ATOM Matrix, we're going to use a blocking software called UI Flow. And primarily, it converts the data stream, which is coming from the FarmBeats hardware over Wi-Fi on a MQTT protocol. It then sends that to the serial port. But the other function that it performs is it selects the particular FarmBeats station that you're interested in. So stay tuned at the end and you'll see an operation of how the different FarmBeats stations are selected. So here's the software, the Node-RED software, which is on the Raspberry Pi. It's quite simple. And you can see all it's doing is it's like data flow. It's taking the data from the USB port and sending it out to the MQTT service. Now, I've only configured dataset 1, but if this was on station 2 or 3, we would add the serial port on the relevant MQTT feed. Also here, I'm snipping the MQTT, and I've subscribed to the Data 1 service, and that means that I can get all the data from Microsoft Excel when it is set up as an agent. And it sends the control information for the light and pump control back via the serial port to the Raspberry Pi. And here's what the UI flow looks like on the Atom. So you can see a matrix there, which is in various places. That's really just painting what the interface looks like on the LED matrix on the Atom computer. And I used that matrix and the LED format to give me some feedback on how I'm progressing through setup. And also when I select a particular station. So to select the station, you just simply press button A, and it increments the station number. And there's a function which shows on the Atom Matrix, both in color, but also numerically, it shows which station has been selected. And the MQTT portion is shown here, where it subscribes, depending on the data set, for station 1, 2, and 3. And it also publishes the data collected by the Raspberry Pi over MQTT. And here are the results. And this shows the data in tab on the FarmBeats spreadsheet. And you can see that all of the columns are activated. And I can select the dashboard of the sensor dashboard tab, and it will graph out the colors that are shown here. These are the bands where the agent is active. If you can see the progress on the graph, that means that the agent is active and will send a message to the FarmBeats hardware to turn on the relay. Alternatively, you can have a look at a single sensor, select the sensor that you're interested in, and you can visualize and see what's happening. And here we're looking at soil temperature. And for the agent configuration, the Microsoft Excel FarmBeats spreadsheet allows us to select up to 3 sensors, and depending on the values, it can combine these and provide a rule that turns on or off the relay. So here you can see the agent is inactive, but it has been activated. And also the data logger, which is working on the Raspberry Pi, has also been activated. And so I'm pleased with the results. The overall goals of having a remote station, which is not dependent on a USB cable, but allows the Excel workstation to be inside, and the FarmBeats kit can work in the garden remotely, and they communicate via Wi-Fi and the MQTT protocol. And the other goal was that I have configured it for multiple stations. So on this project, I've got up to 3 stations, and these are selected via the ATOM computer, which acts like a bridge and relays the data from the MQTT stream to the USB serial port on the Windows PC. So that's all for the time being. Thank you for listening.
This is my Microsoft FarmBeats hardware kit doing its job in the garden. It's just like the original FarmBeats kit, but it has one important difference. It's communicating to the Windows PC, which is hosting the FarmBeats spreadsheet on a PC, and the Windows PC is inside, and it's connected to the FarmBeats hardware that you can see here by Wi-Fi. And the important difference is that we've taken the serial port and connected it back to the USB ports on the Raspberry Pi. So it's identical in all other ways. That is, it's got the sunlight detector, and next to that there's the relay, and it's activated by the agent, which is operating on the Excel spreadsheet. And over here we have the DH11 temperature and humidity sensor, and the other sensors are already connected to the plant. We have a soil moisture sensor here, and that's in the pot plant, and we have a soil temperature sensor over here. And all that information or data is being transmitted to the FarmBeats spreadsheet. What else have we got? We've changed the TTL to USB adapter because the original one from Seed Studio didn't work, and I can't even get a replacement for it from Seed Studio. They just ignore me. This is an alternative, and it works well. So here is the Microsoft FarmBeats hardware inside. So the data from the outdoor hardware is transmitted via Wi-Fi, and it's in the form of MQTT packets which are sent inside. Now previously we used a router that sent that data from the Wi-Fi to a USB and fed that data into the data streamer, and then eventually into the Microsoft spreadsheet. Now this is what we used previously. So this is both a router and another garden station, but we don't really need this anymore, and we've replaced all of that with a single ATOM Matrix computer, which costs around about $15.50 US, and it collects the MQTT packets by Wi-Fi and sends them via this USB cable to the PC. Besides allowing remote control, it also allows multi-stations. So at the moment we're working with up to 3 outdoor stations, but if we want to select a different station, we just simply press the button, and now we're routing station number 2's data to the Excel spreadsheet. And we can also do the same with number 3. So if we go back, there's nothing being routed at the moment. Press the button, and we're now routing the data for the hardware you just saw outside. Now, all that data is being fed into the Microsoft spreadsheet, so you can see that over here, and we can see how that's being graphed. So this is how it comes in, and everything is being supported at the moment. So you can see that it's collecting data, and if we want to see the sensor dashboard, you can see it over here, and the color bands have been set up with the agent configuration. So you can see the colors, and the agent will turn on the relay, which is now on, if the soil temperature is greater than 5, if the air temperature is greater than 15, and if the sunlight is greater than 200 lumens. So you can see that relay is being turned on and off, and that instruction is being sent out by Wi-Fi to the hardware outside. So we'll go back and have a look. There's the live data, and there are the measurements for humidity, air temperature, soil temperature, and we might see what else is on there on the left. So we'll just decrease that. So you can see the sunlight over there too. So that's all the data, and you can have a look at individual sensors, and over here you can see a log of the sensor value, and you can select the sensor over here. So the visible sunlight in lumens is around about 280 and 280. So we can have a look at soil temperature, soil moisture, air temperature, air humidity, and we can go back to visible sunlight. So that's the indoor configuration for the Microsoft FarmBeats using a Wi-Fi and MQTT link instead of just connecting the hardware directly via USB.